Hey guys, we're up to the next topic, which is chapter 13, exponential functions and logarithms. So today we'll just start off with the first exercise, 13a, which is index laws. So all the index laws that we need are listed just here. So to start with, and I think you've seen them before, to start with, we're just going to try to practice using one of these laws at a time, and then once we kind of get the hang of that, we might move over and start using multiple laws to solve problems. But each time we try to simplify one of these, I might go up and touch on the law that we might be using. Okay, so with this first one here, A, we have two bases, like they're the same. We've got x and x, and we can see their times together, they have different powers. So if we look up here, we're looking for this one here because it has the same base. We're trying to find out what happens with these powers here. So what's going to happen is they're going to be added together. So if we go down to this one, our answers are going to end up being x, and we add these two powers together. So it will be 3 plus 2, which gives us x to the power of 5. Now I made a mistake with the letters here. I'm just going to move to the side like that. Okay, so we'll do this one, which is G now. As we can hopefully see, we're using the exact same law. Both of these bases are the same and they're times each other. We're just going to add these powers together. So we're going to end up having 4 to the power of 6, which you could probably work out further as well. I'm just going to leave it there though. Let's go down to this one. This looks similar to what we've been working with, except we've got divided by instead. So let's move up to our laws and try to find which one we're going to be using. I can see that this one here has divided by, so that's what we're going to be doing. Hopefully we can see that we're taking the second power from the first one. So let's go back over here. So y to the power of 6 minus 3, which is y to the power of 3. Done. Now if we go over to this one as well, it's the same sort of thing, isn't it? Except our base is 3 instead. So it'll be 3 to the power of 7 minus 2, which is 3 to the power of 5. Again, you'd be able to work out what that number is as well. Okay, now this one. This one looks a bit different, doesn't it? So we've got, that's supposed to be a Z, by the way. If ever I write a Z, it's got a little line in there, just so you can tell the difference between the two. We've got some base in here, and it's got a power there, but then we've got another power that's outside the brackets. So let's go up to the laws and see if we can find something that looks similar to that. Now it looks like we've ordered these pretty well, because as far as I can tell, this looks like the one we're looking for. We've got a base, a power, and then on the outside of the brackets we've got another power as well. So what we're going to have to do is times those two powers together. So we'll have z to the power of 4, and then we will multiply by that outside power. So that's going to give us z squared. And again, if we move over to this one, hopefully we can see that it's pretty much the same thing, except we've got a different base, a couple of different powers, but it works the same. So we're going to have 6 to the power of 2 times 10, which is 6 to the power of 20. Alright, now this one here looks sort of similar to the one above. So it looks kind of similar to the one above here, except there's no extra power inside here. And this was just like your single letter. There was no other number out the front. This one has a number out the front. Let's go up to our laws and see if there's anything that looks similar to that. Right, now this thing has 2 inside the brackets, and it's got a power on the outside. So that's what we're looking for. So we're going to be using rule 4. And what happens is that power applies to each of the things inside there. So as you can see, it becomes a to the power of n times b to the power of n. Alright, so that 3 is going to apply to both of these in here. So we're going to have 4 to the power of 3 times x to the power of 3. Now we can simplify this one further, but I'm going to leave it for now. Over here is the same sort of thing, isn't it? So that 5 is going to apply here, and it's also going to apply there. So we'll get x to the power of 5 times y to the power of 5. Okay, the next one, e. We've got a fraction inside, so or a numerator and a denominator, and we've got our power on the outside. Let's find a rule that looks similar to that. So I'm looking at this one here. We've got a fraction and then a power on the outside of the brackets. So hopefully we can see that that n is going to apply to the numerator, and it's also going to apply to the denominator as well. So we're going to end up having 1 to the power of 3 divided by 4 to the power of 3. Again, we could, and I will do it for this one, we can simplify that further. So 1 to the power of 3 is 3, 4 to the power of 3 is 64. There we go, we're done. And this one's the same sort of thing. So that 4 is going to apply to the z, and it's also going to apply to the y as well. So z to the power of 4 divided by y to the power of 4. Alright, now this one here, we've got a letter and it's to the power of 0. Let's go up here, letter or just a number or whatever, to the power of 0, and it equals 1. Now with this rule here, it doesn't matter what this base is. This base could be any letter, it could be any number, anything to the power of 0 always equals 1. So anything to the power of 0 always equals 1. Done. Now this next one here, we did use this kind of thing a little bit when we were differentiating. It was one of the exercises there. I can't remember what letter it was. But remember, we don't really like to have negative powers. So the rule we're actually looking at is this one here, more specifically this side. But I'm going to go over here. Remember, all this is x to the power of negative 2 divided by 1. Remember, if you've got a negative power, you can move that part down and it's going to become positive. So you can keep swapping it from the top to the bottom, bottom to the top, but every time it changes from the top to the bottom or the other way around, the sign of the power will also change. So this will become like there's a 1 here as well. That 1 stays at the top, the x moves down, and the power becomes positive. So that's the same as that one. Let's try to do a few that use multiple rules at once now. Okay, so with this one here, when I'm looking at that, just 1 second. Brackets aren't actually needed for this one. When I look at this, I can see we've got those negative powers there. I don't like that. I want that to become a positive 1, and I want that to become a positive 2. So that x can move up, but at the same time that 4 can move down. So we're going to end up having x to the power of 1. You don't need to write that one. And then down here you're going to have 4 squared. So we can further simplify that, x over 16. Now this one over here, we're going to need a few more rules involved here. So I can see that we've got something squared times something to the power of 3. These things here, they're not the same, are they? If they were the same, we could actually use rule 1, but they're not. So instead, I'm going to make sure I apply this squared to all the different things inside here. And on this side, I'm going to apply this cube to all the different things inside here as well. So that's going to become 2 squared. X, remember these 2 and that 2, they times each other, so that's 4. The 2 and the 3 times each other, so that's 6. And now we're going to do the same on the other side over here. So 10 to the power of 3 3 times negative 2, x to the power of minus 6. And that's just a 1 there. So 3 times 1 is 3. Okay. We can start putting some things together, but before I do that, I might just make these more familiar numbers. So 2 squared is 4. And 10 to the power of 3. So 10 times 10 is 100, times 10 is 1000. Okay. Now we've got x's, we've got y's, and we've got normal numbers. We can kind of put it all together. So 4 times 1000 is 4000. Now let's focus on the x's. So x times, or x to the power of 4 times x to the power of negative 6. Remember, these powers are going to add together. So 4 minus 6 is x to the power of negative 2. And these y's, they're going to add together as well. So 6 plus 3, that's y to the power of 9. Now, I don't like my answer with a negative power. We shouldn't really do that. Sometimes the book shows it, but we shouldn't. So I'm going to move that x to the bottom to make sure I show my answer with a positive power. So we're done. That one's finished. Now this is the last, this is going to be the last one for this exercise. I think this is probably the hardest bit, but hopefully we can get the hang of it pretty quickly. Now I'm looking at this base 2, this base 4, and this base 8. They're not the same, are they? So we can't just do our x plus 3x plus 2x. We could if it was 2, 2, 2, or 4, 4, 4, or 8, 8, 8, but it's not. But what I can do, if I look at this 4 here, 4 is the same as 2 squared, isn't it? So I can kind of change that. And 8 is the same as 2 to the power of 3. Right, so I'm going to change that a little bit. So instead of 4, I'm going to make it 2 squared, and that's to the power of 3x. With our 8, that's the same as 2 to the power of 3 to the power of 2x. Right, you see how we've got base 2's now? Now, if we remember back to our rules, what happens when we have something squared or to the power of something, and then you've got another power outside? Hopefully you remember they times together. So this first term is just going to stay the same, we're all good. This next one, it's going to be 2 times 3x, which is 6x. And the next one, 3 times 2x, which is also 6x. Cool, so can we see how the bases are all the same now? If they're all the same, that means we can combine this stuff. So, because it's times there, we're going to add these powers together. So it's going to be 2 to the power of x plus 6x plus 6x. So our answer should be 2 to the power of 13x. And we're finished.